Okay, so this is chapter 10, questions and answers on the chemical calculations. You should have tried all of the questions in your chapterized questions, and let's discuss the answers. So the first question that you had was the main compound in this compound, whatever it is, contains 35% nitrogen and 5% hydrogen by mass. The remainder is oxygen. So how do we get percentage of oxygen? Percentage of oxygen is the remainder of that from the 100. So 100 minus that is 60%. Now determine the empirical formula of the compound. Do you remember how to get empirical formula? You write the percentages, divide each of them with the mass number, then the numbers that come out you divide by the smallest, and it comes out to be 1 to 2 to 1.5. Now you cannot leave it like this because there is no formula with a 1.5 under it. You can't say a formula is NH2O 1.5. We said if one of the ratios comes out 1.3, 1.4, 1.5, 1.6, 1.7, you do not round it up or down. You have to multiply it by a number that changes it into a whole number. So the 1.5 is easy. If you multiply through by 2, the 1.5 becomes 3 and the others are multiplied by 2. So your actual empirical formula is N2H4O3. Now he's saying what is the name of this compound. Now this is a compound that has 2 nitrogens, 4 hydrogens, 3 oxygens. What do you think the actual formula is? The actual formula, if you sit down and think about it, is actually NH4NO3. So this is something with 2 nitrogens, 4 hydrogens, 3 oxygens, and this compound is called ammonium nitrate. So that's the name, and he wants the name. Okay, calculate the relative formula mass of zinc phosphide. How do you calculate it? Zinc in the periodic table has a mass of 65 times 3 plus the phosphorus has a mass of 31 times 2, that comes out to be 257. So your molecular mass of zinc phosphide is 257. Now he says a bag containing 51.4 kilogram, and remember that our masses in the number of moles have to be in grams, not in kilograms. So we're going to use the 51,400 grams of zinc phosphide stored in a factory warehouse was accidentally contaminated with water. Zinc phosphide reacts with water to form zinc hydroxide and phosphine, and he gives you the equation. Calculate the minimum mass of water in kilograms needed to react with all of the zinc phosphide in the bag. So what does he give me? He gives me the mass of zinc phosphide. So the first thing you need to do is get the number of moles of zinc phosphide. Number of moles of zinc phosphide is mass over molecular mass. That comes out to be 200 moles. The next thing is, what is he asking for? He's asking for water. So I relate it from the equation with water. The number of moles from the equation, number of moles of water is 6 times that of zinc phosphide. So that comes out to be 1200. Now what is he asking for? He's asking for mass of water. So the mass is number of moles times mR. Number of moles that's calculated times mR comes out to be 21,600 in grams. He wants the answer in kilogram. That means you divide by 1,000. Okay. When chlorine reacts with concentrated sodium hydroxide, a compound is formed that contains 21.6% sodium, 33.3% chlorine, and the rest is oxygen. How do you calculate empirical formula? Again, you write the percentages of each of them. You divide by the molecular mass of each. The numbers that come out, you choose which is the smallest, and you divide all through with that. That comes out to be 1 to 1 to 3, so that means that my empirical formula is NaClO3. Do we understand that? In another titration, some potassium hydroxide solution was neutralized by sulfuric acid, and he gives you the equation. 25 centimeter cubed sample of 0.2 mole per decimeter cube potassium hydroxide was neutralized by 28.4 centimeter cubed of sulfuric acid. And the first question says calculate the amount in moles of potassium hydroxide. So I need to get number of moles of potassium hydroxide. What does he tell me about potassium hydroxide? He says I have 25 centimeter cubed, that's volume. 0.2 mole per decimeter cubed, that's concentration. So number of moles is concentration times volume, and the volume has to be divided by 1,000 in order to be in decimeter cubed. So that comes out to be 0.005 mole. Were you able to get that? That's easy. Calculate the amount in moles of sulfuric acid. Now, when I get number of moles of something, now I need to relate it from the equation. The equation says 2 moles of KOH react with 1 mole of sulfuric acid. So if my KOH is 0.005, the number of moles of sulfuric acid should be half of that, right? Then I want the concentration of the sulfuric acid. Concentration is that number of moles divided by the volume, and that comes out to be 0.088 mole per decimeter cubed. Okay, sit down and practice all of this. If you are not able to get the answers, practice all of them all over again. Lansfordite is the common name for a form of hydrated magnesium carbonate. This formula shows that this compound contains water of crystallization. When a sample of this is heated gently, the water of crystallization is given off. Eventually, anhydrous magnesium carbonate is left. A teacher gave 5-gram samples of this substance to some students and told each student to heat the sample, then let it cool and weigh it. The students heated the samples for 4 different times. The teacher recorded their results in the table. So he's saying plot a graph of these results. Do you know how to plot a graph of the results? So your graph should look something like this. Small x's along that. And then how do I join it? He says draw a straight line of best fit. So this is the straight line of best fit. So this is the graph that you should have. Now use your graph to predict the mass of a sample after heating for 2 minutes. So where is 2 minutes? That's 2 minutes. So that comes out to be 3.8 grams. Can you see that? So just why the masses of the samples after heating for 4.5 minutes and after heating for 6 minutes were the same. Now if I keep heating the sample and the mass becomes constant, that means all the water has been lost. The teacher told one of the students that the amount of hydrated salt in a sample was 0.03 mole and that the amount of water lost was 0.15 mole. So he already gives me the number of moles of each, and I just do it as if I'm trying to get empirical formula. I divide by the smallest to get the simplest ratio, and the x comes out to be 5. Do you understand this? He already gives me number of moles. So he's saying 0.03 mole of magnesium carbonate has 0.15 of water. So these are number of moles. So you're just trying to get the ratios. Divide by the smallest, that comes out 1 to 5. That means that if 1 mole of magnesium carbonate, then the x is 5. When anhydrous magnesium carbonate is heated strongly, it decomposes. The equation for the reaction is this. Calculate the volume in decimeter cubed of carbon dioxide. So he's looking for volume of carbon dioxide formed when 0.03 mole of the anhydrous magnesium carbonate is completely decomposed. So he's saying I'm starting with 0.03 mole of magnesium carbonate. So the first thing I need to do is get the number of moles of CO2 by relating it from the equation. The equation tells me if 1 mole of magnesium carbonate, then I get 1 mole of CO2. That means that the number of moles of CO2 is the same as that of magnesium carbonate. And then, now that I know the number of moles, he wants volume. Volume is number of moles times 24, and that is 0.72 decimeter. Okay. Sulfur dioxide is used as a preservative in wine. The sulfur dioxide content of a wine can be found by titration. A chemist found that 25 centimeter cubed of a sample of wine reacted with exactly 15 centimeter cubed of 0.001 mole per decimeter cubed equals iodine, and he gives the equation. Calculate the number of moles of iodine. He already gives me volume, he gives me concentration, so number of moles is concentration times volume, and do not forget to divide the volume by 1000 because it was centimeter cubed. Now deduce the amount of moles of sulfur dioxide in the wine from the equation sulfur dioxide and iodine. We have number of moles of iodine, so the number of moles of sulfur dioxide from the equation should be the same. Calculate the concentration of sulfur dioxide. I should know that concentration is number of moles over volume. So I have the number of moles and I have the volume in decimeter cubed, and that comes out to be 0.0006 mole per decimeter cubed. So this is the concentration in mole per decimeter cubed. Now he's saying calculate the concentration in gram per decimeter. That means he's telling me change the moles to grams. So if I have moles, how do I get grams? How do I get mass? Mass is this number of moles times the MR. So instead of having 0.0006 mole in the decimeter cubed, I'm going to have this mass, which is 0.0384 grams. Okay. A concentration of sulfur dioxide that is greater than 0.16 makes the wine unpleasant to drink. So use the value you have calculated to state whether the wine is drinkable. So he's saying if it is more than 0.16, then it's not good, it's not drinkable. Is the mass more than 0.16? No, we got it to be 0.0384. So this is less than 0.16, so this wine is drinkable. Okay, another question. Compound has the percentage composition this, calculate its empirical formula. Calculate the empirical formula should be easy now. You write the masses, divide by the mass number of each one, take from the numbers the smallest and you divide all through by the smallest. It comes out to be a ratio of 1 to 1 to 4. Do not forget that if you do not write that empirical formula in the end, you're losing a mark. Just getting the ratios, that's not the empirical formula. So you have to say that the empirical formula is NaBrO4. That's your answer. A student set up this apparatus to measure the volume of carbon dioxide given off when a sample of a carbonate of a group 2 metal was reacted with dilute acid. So he has something carbonate with acid and he's collecting the gas, which is carbon dioxide. She weighed out some of the carbonate and put it in a conical flask. She then added excess dilute nitric acid. After adding the acid, she placed the bung. Can you see what's a bung? The bung is the thing that they close with the flask with. And delivery tube into the conical flask. She measured the total volume of gas collected at room temperature and pressure in the measuring cylinder. Okay. Then the question is, okay, her results are shown in the table. So mass of the carbonate was this, and the volume of gas collected was this. Now calculate the number of moles of CO2 gas collected. So if I have volume of gas, how do I get number of moles of the gas? Number of moles is the volume over 24. So the volume, remember, if he gives me the volume in centimeter cubed, I have to divide it by 1,000 before I put it into the equation. So I end up with 0.006 mole of CO2 gas. Then he says deduce the amount of moles of the carbonate that reacted. So I need to look at the equation. Where is the equation? Okay, where is the CO2 and where is the carbonate? You can see that 1 mole of carbonate gives 1 mole of CO2. So if I have a certain number of moles of CO2, this is the same as the number of moles of carbonate. Using the mass of carbonate, which he gives in the table, and your answer to this, calculate the relative molecular mass. So you have a mass of carbonate. Can you remember what the mass of carbonate was? The mass of carbonate was 0.888 grams. Okay, so the mass of the carbonate divided by the number of moles, that should give me the MR. So I find that the MR of this compound is 148. So this is the compound as a whole. Calculate the value for the relative atomic mass of the group 2 metal X and use your periodic table to suggest its identity. Now, I have calculated that the molecular mass of X carbonate is 148. So the X with the carbon with the 3 oxygens is a total of 148. So what is the X? The X comes out to be 88. So that means that the mass of the atom X is 88, and I look at the periodic table and find out which one has a mass of 88 and which one has a large number 88. I find that that is strontium. Okay, after the student had completed the experiment, she was told that the metal carbonate was supposed to be calcium. She got it strontium, but she's saying it was supposed to be calcium. She calculated that 0.88 grams of calcium carbonate, if it was calcium carbonate, then it should have given 213 centimeter cubed. She was certain that she had measured the mass of the metal carbonate correctly, so just 2 reasons why the volume of gas she collected was less than what she should get. We said usually when we're collecting a gas from an experiment, usually you will get less than what you got. And this is carbon dioxide gas. So the carbon dioxide gas that is collected in the measuring cylinder, she collected less than what she should. What do you think went wrong? So either some gas was lost before closing the bung. Can you see the bung? Or some of the gas dissolved in water. Remember that carbon dioxide is a gas that dissolves in water. So if you're collecting the carbon dioxide over water, some of it will dissolve in water. Okay? Magnesium reacts with dilute hydrochloric acid. The equation for the reaction is this. And he says 0.096 grams of magnesium was added to this of hydrochloric acid. First of all, calculate the amount in moles of magnesium. What is the number of moles of magnesium? Number of moles is mass of a molecular mass, because he's giving me a mass in grams. So the 0.096 over the 24, that comes out to be 0.004 mole. Now calculate the number of moles of HCl in this. He gives me a full information about HCl, so I'm not going to get it from the equation, I'm going to get it from his information. And we said if he gives me information about both reactants, then he's looking for which one is excess and which one is limiting. So I'm going to use the information he gives me, 25 centimeter cube, 0.4 mole per decimeter cube, to get the number of moles of HCl. That comes out to be 0.01. Now use your answers to determine which is excess. How do we determine which is excess? The magnesium is 0.004. From the equation, the number of moles of HCl needed is what? The equation says that the number of moles of HCl is twice the number of moles of magnesium. So the magnesium is 1, the HCl is 2. So if I'm starting with 0.004 moles of magnesium, I need how much of HCl? I need only 0.008, but he put 0.01. Can you see that 0.01 is more? So the HCl is excess, and that is because the number of moles of HCl needed is twice that of magnesium, and what I have is more than that. So the HCl is the excess reagent. Do you understand how we thought about this? Okay. Equation for formation of ammonium nitrate from ammonia is this, and he gives me information about nitric acid and about ammonia, and he's telling me calculate the concentration of nitric acid. So what is the information he gives me? He says 25 centimeter cubed of ammonia. Of concentration this. So for ammonia, he gives me volume and concentration, so I can get number of moles of ammonia. Then he's asking about nitric, so I relate this from the equation. If I know number of moles of ammonia, that is the same as number of moles of nitric from the equation, because the equation says 1 of ammonia reacts with 1 of nitric. Now I know number of moles of nitric, and he says the volume is 15, so I can get concentration. Concentration is number of moles over volume, so that would give 0.5 mole per decimeter cube. Were you able to get this answer? I hope so. Okay, the apparatus in the diagram is used to heat a sample of hydrated copper sulfate. So he has copper sulfate, 5 water. Calculate the maximum mass of water that could be collected when a sample of hydrated copper sulfate of mass 2.5 grams is heated. So I'm starting with 2.5 grams of copper sulfate, 5 water. How much water should I get? So first of all, I need to get the number of moles of the hydrated copper sulfate. Number of moles is the mass over the molecular mass. He already gives me molecular mass, so I don't need to sit down and calculate it, and that comes out to be 0.01 mole. Now, I look at the equation. That means I should get how many moles of water? The equation tells me that the number of moles of water is 5 times that of the hydrated salt. So the number of moles of water is 5 times this, which is 0.05 mole. And he's asking about mass. Mass is number of moles times mR. So the number of moles times the mR of the water, that comes out to be 0.9 grams. Okay? He gives me here information, and he's asking for the empirical formula. Again, empirical formula, you just write the percentages, divide by the molecular masses of each one, and please note that Ti is titanium. There are several things in the periodic table that are starting with a T, so don't mix it up with something else. You're looking for Ti. Ti is in the transition metals, at the beginning of the transition metal somewhere. Anyway, the mass of titanium is 48. Then the numbers that come out, I divide by the smallest, and then the ratios is this, so the empirical formula is this. Okay? Potassium hydrogen carbonate decomposes on heating. 3 possible equations for the decomposition of this. So he's starting with potassium hydrogen carbonate, and he doesn't know, is it supposed to give me K2O, or is it supposed to give KOH, or is it supposed to give K2CO3? And he's starting with 8 grams of potassium hydrogen carbonate. And in the end, the solid that comes out, which he doesn't know what it is, K2O or KOH or K2CO3, the solid was 5.52 grams. So he's trying to determine, is this solid K2O or KOH or K2CO3? So we're going to calculate the number of moles. The number of moles of the 8 grams of potassium hydrogen carbonate is mass over molecular mass, so I calculate it as 0.08. Now, if the substance that comes out is supposed to be K2O, then the 5.52 grams are K2O, and K2O has a molecular mass of this, so the number of moles is this. Now, if it is supposed to be KOH, and the 5.52 grams is supposed to be KOH, then I can divide it by the molecular mass of the KOH to get the number of moles. But if the K2CO3 is the 5.52 grams are actually K2CO3, then I need to divide it by 138 in order to get the number of moles. And then I look at the equations. The equation 1, number of moles of KHCO3 should be twice the K2O. So if the KHCO3 is 0.08, this should be twice the K2O, but that actually it is not. The K2O is not half of the 0.08. So that means that equation 1 is wrong. Now, equation 2, KOH, if it is KOH, is 0.099. But from the equation 2, the number of moles of KHCO3 should be the same as the number of moles of the solid that comes out. So if it is 0.08, I should actually get 0.08. I didn't get 0.08, so that means equation 2 is wrong. Now in equation 3, the equation 3 says that the number of moles of the solid form should be half the number of moles of what I started with. So if I started with 0.08, the number of moles of the solid form should be 0.04, and that is correct. So it is equation 3 that is correct, since the number of moles of solid form is half the number of moles of KHCO3, and that agrees with the equation. Do you understand that? Okay. Magnesium chloride can be made by reacting excess magnesium carbonate with dilute hydrochloric acid, and this is the equation. In one experiment, 0.05 mole of magnesium carbonate is added to 0.08 mole of HCl. So show by calculation that the magnesium carbonate is in excess. Now, the equation tells me what? The equation tells me that the number of moles of magnesium carbonate should be half the HCl. Is it half or more? Well, actually it is more. The number of moles of magnesium carbonate needed to react with 0.08 is half of that. So I need 0.04 mole, and this is less than what he actually added. That means he added too much, and that means the magnesium carbonate is excess. And we said once it is excess, that means you don't use it for any calculations after that. Calculate the maximum volume in centimeter cubed of carbon dioxide measured at room temperature and pressure that will be obtained when 0.08 mole of HCl react completely with magnesium carbonate. So I'm going to relate my carbon dioxide to the number of moles of HCl, not magnesium carbonate, because magnesium carbonate is excess. So we say number of moles of HCl is 0.08. Now look at the equation and decide what would be the number of moles of CO2. Obviously, the number of moles of CO2 is half of that, so that's 0.04. And then I can get the volume of CO2. The volume of CO2 would be the number of moles times 24. Okay? In another experiment, 0.05 mole of magnesium carbonate reacts with excess HCl. A yield of 5.5 grams is obtained. Calculate the percent yield. So here we're starting with 0.05 mole of magnesium carbonate. Now, it should give magnesium chloride. Let's look at the equation again. From the equation on the top here, the number of moles of magnesium carbonate is equal to the number of moles of magnesium chloride. So now if I start with 0.05 mole of magnesium carbonate, then the number of moles of hydrated magnesium chloride should be the same. Okay, and then the mass of the hydrated salt is number of moles times MR. The MR I calculate as this, so the mass is number of moles times that, and that means that I should get 10.15 grams. But what did he get? He got 5.5, then the percent yield is 5.5 over 10.15 times 100, and that gives me a percent yield of 54%. Okay, so just why the percentage yield is less than 100? We said always what you actually get in the lab is always less than what you should get. That means either the magnesium carbonate was not pure, either what we started with was not pure, or the solution was not left to cool long enough, so not all the crystals were formed, or when we tried to separate the crystals, some of the crystals were lost during filtration. These are all the possible reasons why your percent yield is always less than 100. Okay, this is another question about empirical formula, and you should be able to get this correctly. The percentages divided by the mass, and then what comes out you divide by the smallest. Okay, a student is asked to find the concentration of a solution of sulfuric acid. He plans to titrate a known volume of sulfuric acid in a conical flask with 0.4 mole per decimeter cube sodium hydroxide solution using phenolphthalein as an indicator. In this titration, 23.85 centimeter cube of sodium hydroxide are needed to neutralize. So calculate the number of moles of sodium hydroxide. He has a concentration up there. He has 0.4 mole per decimeter cube of sodium hydroxide, and he gives you the volume. So the number of moles is concentration times volume. Remember to divide the volume by 1000. So the number of moles of sodium hydroxide is this. Now, he says the student used 25 centimeter cube of sulfuric acid, so that is the volume of the sulfuric acid. Calculate the concentration of the sulfuric acid. So in order to calculate the concentration, I need to know the number of moles. If I have a certain number of moles of sodium hydroxide, what would be the number of moles of sulfuric acid from the equation? Number of moles of sulfuric acid will be half of that. And then I can get concentration, which is number of moles over volume. So the concentration comes out to be 0.1. Okay, 1.3 grams sodium is burned in oxygen. The product is an oxide of mass, so the total mass is 2.34. The sodium alone is 1.38, so you can get the mass of oxygen as the difference and then calculate the empirical formula. Normally it comes out to be NO. Now, the oxide has a relative formula mass of 78. Determine the molecular formula of the oxide. Now, if you have the empirical formula and you're trying to calculate the molecular formula, how do we do that? We first calculate the molecular mass of the NaO. Molecular mass of the NaO, as it is 23 plus 16, which is 39. Now, he's telling me that the compound has an actual molecular mass of 78, not 39. So this 78 has how many 39s in it? This is twice what we got. So the compound is not just one Na and one, sorry, that's supposed to be Na. This is supposed to be Na. Na2O2. Okay? The equation shows the reaction of this oxide with water. Complete the equation. So that's potassium hydroxide. And then he says potassium superoxide reacts with carbon dioxide to produce potassium carbonate. And he's starting with 5.5 million tons of carbon dioxide released into the atmosphere each day. Calculate the mass of potassium superoxide needed to react with this mass of carbon dioxide. So if I have 5.5 million tons of carbon dioxide, I calculate the number of moles. A ton is times, or millions is times 10 to the 6. So the number of moles is mass over the molecular mass of CO2, and then from that I relate it with the number of moles of KO2 from the equation. The equation says 4 KO2 reacts with 2 CO2. That means number of moles of KO2 is twice that of the carbon dioxide, and then from that I can get the mass of the KO2, which is number of moles times mR. Now that is the mR 71, so the mass is this, so that comes out to be 17.75 million tons. Okay, so that's the end of the questions. Hopefully you were able to do this. If you were not, please go over it again, try the questions again, determine where you're making a mistake, and make sure that you don't repeat this mistake, and get ready to do a quiz on this. Okay?